Hello. In this class, we'll discuss velocity and acceleration diagram with 6 linkages. So this is the given problem statement. So what we have, crank OA is given, which is having angle of 50 degree. The crank speed is available, 20 radian per second. That rotates in clockwise direction. Then we have the orientation of this fixed point O1 and O2. Horizontally, it is differ by 0.6 meter and vertically 1 meter. Then again, we have the slider orientation with respect to O1, it is 0.6 meter parallel to O1 position. Then we have the dimensions of crank O1 is 0.5 meter. Then AB is available 1 meter. O2B distance is available 0.75 meter. BC distance is available 1 meter. That means this part is O2C 1.75 meter is available. Then we have CD part 1.75 meter. Okay, and the question is we have to determine the velocity and acceleration of slider D, angular velocity and angular accelerations of link CD. Okay, so output link, we have to find out angular acceleration velocity for output link, angular velocity of output link. At the same time, we have to determine velocity and acceleration for slider D. Okay. Now, first we'll discuss how to plot this mechanism, and then we'll solve velocity and acceleration level. Now, initially we have to locate fixed point O1 and O2. Okay. So first we'll draw parallel line, 0.6 meter, 0.6 meter, two parallel lines, and we will locate orientation of O1 and O2. So horizontally it is 0.6 meter and vertically it is away 1 meter with respect to O1 point. So just we locate part O1 and O2. These are the fixed point. Then we locate the crank O1A. Now the value of O1 is available 0.5 meter. So you can take scale 1 centimeter is equal to 0.1 meter, and this line will be 5 centimeter that we can plot. Okay. Then next we can locate that AB distance, which is 1 meter. So just draw a line of 10 centimeter and draw one arc. Again line O2B. This O2B is 0.75 meter, means 7.5 centimeters. So intersection of this O2B and AB will define orientation of B. So just connect AB and O2B. Extend that part up to 1.7. This O2C is 1.75 meters. So and this is 0.75 meter. So extend that BC line up to 1 meter, means 10 centimeter. So this O2C distance is overall it is 17.5 centimeter. After this, we have given a CD 1.75 meter. That means we have to take distance 17.5 centimeter in compass, and we have to cut that distance on vertical line so that we get orientation of slider. So this is the orientation of slider. So in this way, we can draw actual configuration diagram. Okay. Now next part is we have to draw velocity polygon based on this data. So again, we can form this table. We have length, angular velocities available, linear velocities, v is equal to r omega, and the orientation. Okay. So the lengths are O1 0.5 meter, O2B 0.75 meter, O2C 1.75 meter, AB is available 1 meter, and DC is 1.75 meter. And these are the velocities. Okay. So angular velocity for crank OA is available 20 radian per second. So you can find out linear velocity of that particular crank VA with respect to O. It is R omega 20 into 0.5 10 meter per second. So again, you have to take some suitable scale while plotting velocity polygon. So we'll first mark 0.4. Then this will be the perpendicular line for OA. Velocity is tangential to motion. So we have to draw a perpendicular line. So this OA will be of 5 centimeter. 1 centimeter is equal to 2 meter per second. So 2 meter per second, that is our scale. This is of 5 centimeter. After plotting K, we need to draw AB. Okay. So just draw second perpendicular for point B, that is VAB. Then again draw one more perpendicular for O2B. So intersection of these perpendicular will define orientation of B. So connect A and B. Okay. After this, extend that perpendicular up to C. So how we can look at C? Just we can take the ratio O2C upon O2B is equal to OC upon O. So by taking that part, we have this value 95.6. So this will be of 95.6 mm. We can look at C part. Okay. Then next, from C, we have to draw one perpendicular, that is for CD line. And such slider is moving in vertical direction. So then we will draw one vertical line. So intersection of vertical line and this perpendicular CD will define orientation of point D. So connect D and O, connect D and C. Okay. So this is the overall velocity diagram. Now from this diagram, we can measure the various angular velocities. So we have to determine angular velocity of O2B. So this will be VB upon O2B. So this velocity is available 4.1 centimeter. VB is 4.1 centimeter. That distance is available 4.1 into scale. That is 8.2 meter per second square. So 8.2 upon O2B, this distance will be 0.75. So we have omega B 10.93 radian per second. Similarly, for O2C value, for O2C again you can find out this part angular velocity of BC. So again by taking that overall OC value 9.56 into 2, 19.12 meter per second. Again divided by O2C distance 1.75 meter. We will get same velocity because this point B and C are on same link. That's the angular velocity for link omega BC and omega OB will remain same. Okay. The next part will be angular velocity for AB. So angular velocity of AB will be AB. AB is available 1 meter. Okay. So this is already available 1.25 into 2.5 meter per second. Okay. And then angular velocity of CD will be DC distance into scale. So what is DC distance? This is the DC distance. This is around 7.3 centimeters, 7.3 into 2. That will be 14.75 meter per second. Okay. So you can calculate UDC is 4.7 into 9.4 meter per second. And this velocity of slider D with respect to O, 7.35 into 2, 14.75 meter per second. So this is the velocity of slider D, and this will be velocity of CD. That will be 4.7 into 2, 9.4 meter per second. So in this way, we can determine velocity. Once the velocity is available, then we can find out the omega DC. 9.4 upon length 1.75. So that value will be 5.37 radian per second. So this is all about calculations of velocity for CD link and velocity for slider D. Okay. Now next part is acceleration diagram. Now again for acceleration diagram, we have normal component of acceleration. Tangential is 0 because crank rotates with uniform speed. Normal of O1A, normal component of AB, and normal component of O2B. That will, and then for normal component of CD and orientation of slider D. So first we'll determine the normal component value by taking R omega square. So R will be the dimensions and omega will be the angular velocity of respective links. So just put that value of normal component for acceleration for point A with respect to O. So that value is around 200 meter per second square. Then second normal component for AB, 6.25 meter per second square. Normal component of that O2B will be R omega square, 89.65 meter per second square. Normal component of CD will be DC into omega square, that is 50.5 meter per second square. And then we have to plot a tangential component. Now look at the values for normal component of crank O1A, 200 meter per second square. Now we have to take actual appropriate scale to plot the acceleration diagram. So we take scale 1 centimeter equal to 40 meter per second square. Okay. So just look at the part. So we'll just look at O1 and O2. That will be our first part. Now acceleration component is towards the origin, but in opposite direction. That is parallel to link. Normal component is parallel to link, but in opposite direction. So this will be O1A, which is of 5 centimeter. Then we'll draw perpendicular component of AB. Okay. So this is the perpendicular component of AB. Then next, this perpendicular component of O2B. So this will be O2B parallel to this link O2B. What we have, which is around 159.9, that is of 4 centimeter. Okay. So O2B 89.65 is available. That is around 2.2 centimeters. So this will be perpendicular parallel to link, and then this will be the perpendicular link. So this O2B and this O1A component, that means we can reach towards point B with respect to A. We can reach towards point B with respect to O2 line. So these two perpendicular will define orientation of point B. Okay. So just look at that B dash part. So you can connect O dash, B dash, O1 dash, B dash. Okay. And then you can locate C. Again, locate that extended portion of C. You have to take that equation O2C upon O2B is equal to O1 dash, O dash C dash upon O dash B dash. So by putting this value, we have O dash C dash value that will be around 95.6. So you can mark that part and you will get C dash location. Okay. We are extending that B dash line up to C dash, and that is up to 95.6 mm. Now next from C again, look at the D orientation. It is an upward direction parallel to CD. We have to draw this line. Parallel component that is normal component of acceleration CD having magnitude 20 meter per second square. That means this line is 0.5 centimeter. Again, draw a perpendicular component, and then one more component, that is first adder, a straight line. Okay, so this is perpendicular to CD, which we can plot. Okay, and this is a vertical line. The intersection of this, both the lines will define orientation of D dash. So just plot that D dash, connect D dash and C dash. Okay, and then we can measure the acceleration. So we have to find out this acceleration of D. So just measure that part, multiply by scale, you will get acceleration. So acceleration of slider D is 340 meter per second square. Okay, so it is around 8.5 centimeter. This line is around 8.5 centimeter. So this value is 340 meter per second square. And angular acceleration of CD is tangential component upon CD. So tangential component, what is the tangential component? This is 20, that is 0.5 centimeter. So 20 upon 1.75 meter. So that will define the tangential component 11.428 radian per second square. So in this way, we can calculate acceleration of slider D and angular acceleration of CD. Okay. So this is the overall process to plot the velocity and acceleration diagram for these 6 links.